All right, welcome. It is week 6, class number 1, first class of chapter 8. 8.1 is what we're going to cover today. You have some 8.1 homework. We should have some class time to begin it, maybe 15 minutes or so, maybe 10 if we go a little slower. So let's begin with the notes. First off, we're going to talk about ratios. What is a ratio? It's a quotient. A quotient of two numbers. Now, what does the word quotient mean? Quotient means what? If it were sum, it would mean addition. So quotient means division, right? So here's some examples of a ratio. One example is this, or 5 to 3. These are the same thing. Or 5 to 3. All three of these are the same thing. Or 5 divided by 3. So all of these mean the same thing. Okay? All right. Now, a simplified ratio contains no decimals. By that I mean if you had like 2.5 over 5, you wouldn't report the ratio like that. You would report it as 1 to 2. 1/2. Very good. Okay, so on occasion with the homework especially, there are some like unsimplified ratios that come up, but just know if you're reporting an answer, simplify the ratio as much as you possibly can. All right, let's talk about proportions. A proportion is an equation stating two ratios, two or more ratios are equal. Are equal. So we got some examples of this. We got 1 to 2, which is the same thing as like 5 to 10, right? That's a proportion, two ratios that are equal to each other. Or if we want to make it with some letters here, A to B is equal to C to D. If we were going to list this out, we would list it out like top left first, A, bottom left second, B, top right third, C, bottom right fourth, D. Now, notice A and D, where are they located? They're on the outsides, right? A and D are located on the outsides. And in our proportion, they're located in the top left and the bottom right. So the top left and the bottom right would be what we call the extremes. So the extremes are A and D. A and D are the extremes. So looking at this other proportion over here, what are the extremes of 1/2 is equal to 5/10? So A is in the top left, D is in the bottom right, 1 is in the top left, 10 is in the bottom right, 1 is an extreme, 10 is an extreme. And if you list it out, top left, top right, bottom right, if you list it out like that, you can see the extremes are, first and last. And then we also have the means. The means are the other two. So the means would be B and C. Bottom left, top right. B and C. So these are two vocabulary terms you've not seen before. They're not overly complex. The top left, the bottom right, those are the extremes. The bottom left, the top right, those are the means. So just keep that in mind today. So over here in 1/2 equals 5/10, 2 and 5, those are the means. Questions on that? Okay. Let's take a look at example 1 here. The ratio of the measure of an interior angle to the measure of an exterior angle of a regular polygon is 7 to 1. Okay, before we go any further, how does one interior angle in a regular polygon relate to one exterior angle of that same polygon? They're supplementary. Good. So we know that this interior angle and this exterior angle, they're going to be supplementary. Now they're in the ratio of 7 to 1. What to what, it says here? Interior angle to an exterior angle. So we'll say interior angle to an exterior angle. They're in the ratio of 7 to 1. And you told me they're supplementary, right? So we should call an exterior angle x. Okay, we'll say exterior angle equals x, and then you guys take it from here. So first create an equation with x, and then find the number of sides in that polygon. So I think you can take it from here. This is very similar to what was on your test last week. If you're at home, I'm going to pause the video now. You do the same. So our equation is going to be 7x plus x, right? That's our interior angle plus our exterior angle equals 180. They are supplementary. So we get 8x equals 180, x equals 22.5. And then Brent, how can we finish this out? We're trying to find the number of sides of the polygon. X is 22.5, which is our exterior angle. What can I do?
360 divided by 22.5.
There you go. 360 divided by 22.5. And that is equal to what? 16. So we have a 16-sided figure, a 16gon. Questions on that? Okay. Taking a look at number 2, we're asked to solve this proportion. Does anybody know what method we use to solve this proportion? What? Yeah, cross multiplication. So we got a proportion. That's a ratio equal to another ratio, and you have one unknown. The one unknown here is x. We can cross multiply. So that means the extremes are multiplied together. X plus 4 times 7. So be careful on this. Here's where you're going to make a mistake if you make a mistake. 7, and then in parentheses, x plus 4. You have to multiply all of x plus 4 by 7, not just part of it. So if you don't put x plus 4 in parentheses, you're not going to multiply all of it by 7, just part of it. That's going to be equal to, the means are also multiplied together. Same thing, 3 multiplied by all of 2x minus 5. So that would be 2x minus 5 in parentheses. All right, take a moment now and solve for x. If you're at home, I'm going to pause the video now.
Distribute the 7.
All right, so we'll distribute the 7, and we get 7x plus 28 is equal to, what do I do on the right side?
Distribute the 3.
Distribute the 3. We get 6x minus 15. And let's solve for this, and we get, we subtract 6x on both sides. We get x equals, subtract 28 from both sides, negative 43. And yes, x equals negative 43. Take a moment now and check this. How can you check it? Anybody have any ideas? Plug it back in. So plug in negative 43 into the original and see if those two ratios are in fact equal to each other. They should be if you did everything right. And so when we sub back in, and we find out that negative 13 is in fact equal to negative 13. And yep, that checks out. Very good. Any questions here? Means extremes products theorem, that's just cross multiplication, right? What we just did, cross multiplication, is the means extremes products theorem. So Mr. Rivers, why do we have to know that? Well, it's going to be a reason and a proof. Means extremes products theorem is going to be a reason and a proof. What is it? In a proportion, the product of the means is equal to the product of the extremes. Okay, and so we'll say if A over B is equal to C over D, then A times D is equal to B times C. Okay. So looking at example 3, it says which of the following are equivalent to A over B is equal to C over D. Now remember, we just said A over B is equal to C over D. If that's going on, then AD must equal BC. So this is just a matching game. We're going to figure out, of these 5 below, which of these 5 are equivalent to AD equals BC. Let me do the first one with you. The extremes, that'd be B times C, BC, right? B times C is the extreme multiplied by the other extreme, is equal to the product of the means, that'd be A times D. So, is BC equals AD equivalent to AD equals BC? Yes or no? Yes, they are equivalent. So we're going to circle A. So go through the other 4, determine which of these 4 are equivalent to AD equals BC. So take a couple minutes and do this. It takes a little bit of time. If you're at home, pause the video now, try it on your own. All right, so let's take a look at B all together. We're going to multiply the extremes. That'd be A times D, so that's AD is equal to C times B, that's CB. Is that equivalent to AD equals BC, yes or no? Yes, so we're going to circle B. Very good. Let's take a look at C. C, the extremes, that'd be A times C, that's AC. Let me do this in blue so it pops. AC is equal to the means, that'd be D times B, that'd be DB. So is AC equals DB equivalent to AD equals BC, yes or no? No, it is not. So we're not going to circle C. Let's take a look at D. Remember, we have to use the distributive property here. A plus B multiplied by D, that's D, multiplied by A plus B equals the means multiplied together, that is B multiplied by C plus D. Okay, so we distribute the D and we get dA plus dB equals dC plus BD. So we're looking at this. At first it looks like no, but notice on the left side we have dB. On the right side we have BD. These are the same thing. So I'm going to subtract dB from both sides, and when I do that, these go away and those go away, and we are left with dA equals BC. So is dA equals BC the same thing as AD equals BC? Yes. So D is equivalent as well. Questions on that? We had to distribute. We noticed we had the same product on both sides, which allowed us to eliminate them. There you go. E, the extremes, that's A multiplied by B plus D equals the means, that'd be B multiplied by A plus C. We distribute and we get AB plus AD equals BA plus BC. And as I look at this, I see I've got AB on the left, I've got BA on the right. Those are the same. I'm going to subtract AB from both sides. And when I do, those are eliminated, and those are eliminated. So now we're left with AD equals BC, and you can see those are equivalent, so I'm going to circle E as well. Any questions on those? Nothing? All right. Example 4. If 5x equals 8y, find the ratio of x to y. When we say the ratio of x to y, we mean x over y. So what we need to do is we need to rearrange this equation so that x is in the numerator, y is in the denominator, and they are isolated. So take a moment and see if you can do that. Rearrange this equation so that x and y are isolated. X is in the numerator, y is in the denominator. We're looking at 5x equals 8y. We want the y to be in the denominator. We want the x in the numerator. Well, the x is already in the numerator, so the x does not have to move. The y does have to move. So I'm going to divide by y on both sides. And once I do that, I end up with 5x over y equals 8. Questions about that first step? Okay, so now we have x over y, which is exactly what I want, but I've got this 5 up here in the numerator, so I'm going to divide by 5 on the left, divide by 5 on the right. 5 over 5 is 1. They're gone. We are left with our answer of x to y, or x over y, is equal to 8 to 5. So all we did was use like very basic pre-algebra to rearrange that equation to isolate x over y. Questions over that? Okay. That one gave some people a hard time for some reason. I'm not sure where the disconnect was, but all right, find the fourth. This should say proportional. I think it does say proportional on your document. So when we say the fourth proportional, we mean 4 is going to be A, 8 is going to be B, 12 is going to be C, and then D is going to be D. So with that in mind, A over B is equal to C over D. With that in mind, set up a proportion and find the fourth proportional. So A is 4 over B is 8 equals C is 12 over D is D. Now, something as simple as this, you can tell that 4 over 8, that simplifies to 1/2. So 12 over D is going to have to also be 1/2. This one is simple enough. If you look at it and you just know that D is equal to what? 24. I'm okay with you just writing the answer. It's so straightforward. But if it were not this straightforward, we would have to apply the means extremes products theorem. That'd be 4D is equal to 8 times 12 is, was that 96? We divide both sides by 4 and we get D is equal to 24. So either way, whether you use cross multiplication or not, that's how it's done. All right, let's talk about the arithmetic mean. The arithmetic mean is the mean just like you've always learned it. So think about when you're in elementary school, like 5th grade or whenever it is, 4th grade maybe, where you learn about how to find the average of something. How do we find the average of like a set of numbers?
Divided by the number.
Correct, yeah. Add up all the elements in the set, as I say, and divide by the number of elements in the set. That is the arithmetic mean. So this is something you already know how to do. It is not new. So we're going to say it's the average of 2 or more numbers. And specifically, we mean the mean of 2 or more numbers. So that's not new. This next part is new. And so if you've checked out mentally, please check back in now, because this is something you're not going to come across intuitively. It's something you have to just pick up right here. So the geometric mean. If the means, which is, remember, B and C, right? B and C. If the means in a proportion are equal, right? So if B is equal to C, then either mean, it's the same, right? If B is equal to C, then when I say either mean, they're the same. Then either mean is called the geometric mean. Sometimes called the mean between the extremes. but also called the mean proportional. All right, so mean proportional and geometric mean, they are synonyms for each other, so just do your best to memorize that. Geometric mean, mean proportional, they mean exactly the same thing. And I've got an example for you to show you what this looks like. So let's say x is the geometric mean. So x is the geometric mean. Then we would say, well, let's read this one more time. If the means in a proportion are equal, b is equal to c, then either mean is called the geometric mean. So if x is the geometric mean, x is a mean, and x is a mean. Remember, the means are b, bottom left, and c, top right. And then in the top left, we're going to put a, and the bottom right, we're going to put d. So this is the way it always looks. The means are always the same in a geometric mean. Okay? Try the next one on your own. Find the arithmetic mean between 5 and 20. Don't overthink this one. Should just be 5 plus 20 divided by 2. So we get 25 divided by 2. The arithmetic mean is 12.5. Questions on that? Remember, arithmetic mean is just the average like you've been taught since elementary school. Now, here's the different one. Find the geometric mean. Now, what's special about the geometric mean? It is equal, right? We're talking about b and c. They're equal to each other. So we're going to write equals. Find the geometric mean between 5 and 20. What are 5 and 20 going to be? What? The extremes, right? So we'll put 5 up here, 20 down here. What do you think we should put as our means? X and X. So that's the setup for that. In the geometric mean, the means are equal to each other. We don't know what they are, but we do know they're equal. We do know the extremes are 5 and 20. So with that in mind, go ahead and solve for X. I'm going to pause the video now. 5 times 20, that's 100. That is equal to x times x, which is x squared. How can we solve for this variable? Take the square root of both sides. So the square root of 100 is equal to the square root of x squared. There's something that has to happen here. Yeah, so whenever we take the square root of a variable, like we do here, we have to put plus or minus in front of the other side. So it's going to be plus or minus 10 is equal to x, okay? So we get x equals plus or minus 10. Now let's plug this back in and prove that both plus and, or positive and negative 10 both work. So that'd be 5 over 10 is equal to 10 over 20, right? So that's 1/2 and that's 1/2, so that checks out, doesn't it? That's good. Now let's put in negative 10. 5 over negative 10 is equal to negative 10 over 20, and you can see that's negative 1/2, and that's also negative 1/2, so that also checks out. So I can prove to you that both the positive and the negative value of 10 solve that proportion, okay? So just keep that in mind. Whenever you take the square root of a variable, you got to put that plus or minus on the other side. All right, folks at home, that's all I got for this class. Your homework has been sent to you. Make sure you complete it. Give your best effort, and we'll see you next time.